Okay, this problem deals with simple linear regression, and it's from Chapter 12, Section 7, and it's an example that you can follow that will be very similar to what the question from the third exam is like. Basically, what you're going to find is you'll have a computer printout, and there'll be about 12 questions that you need to answer relative to that printout. You don't need to memorize the questions. You just need to know where to look on the printout and to be able to interpret the results so that you can answer the questions. Okay, so this is the problem. It is problem 1254, page 445. And it says a survey by the Pew Research Center found that social networking is popular in many nations around the world. The file, which is called Global Social Media, contains the level of social media networking, which is measured as a percent of individuals polled who use social networking sites, and the GDP per capita based on purchasing power parity for each of 24 selected countries. So these are the questions. State the regression equation. Interpret the meaning of the B0 and the B1 values in this problem. Predict the average percent of social media usage if GDP per capita is 10,000. Is there anything useful in the equation? And here we want to examine the F value to answer the question. Provide the coefficient of determination using the adjusted value and interpret its meaning in the problem. Provide the correlation coefficient. Does it indicate a significant relationship between GDP per capita and the percent of social media usage? G, should the regression model be used to predict social media usage? How do you know? Examine the residuals to see whether they're normally distributed. At the 0.05 level of significance, determine whether the explanatory variable makes a significant contribution to the regression equation. Use the t-statistic to answer this question. Explain the meaning of the p-value for the coefficient. Set up a 95% confidence interval estimate of the true population slope and interpret the meaning of the interval. Okay, so these are the several sections of the problem. It's a lot of information that we want to know, but we'll go through it step by step, pretty slowly, and enable you to answer the questions. All right, so first question says, state the regression equation. So I'm looking at the regression statistics, summary values, and it gives me an intercept coefficient and a GDP per capita coefficient. So the intercept is where the regression equation crosses the y-axis. And so that value would be the same as B0 when we look in our equation. And GDP per capita is the coefficient or the number that goes with the x1 independent variable in our equation. So those are the numbers, 22.06889636. If we round off to 4 decimal places or so, this is what the equation is going to look like. 22.0689 plus 0.00205 x1. Okay, and you could say plus E there, which means there may be some error associated with using this equation, and normally there would be, but it's not crucial to have that. So that's part A. That's all I have to do is write down the equation in the correct form. The correct form is y hat equals B0 plus B1 x1, where B0 is the intercept, and here's the intercept, and the slope is the B1 value that corresponds to x1. Okay, that's part A. Just write it down in the form of an equation. I don't want the numbers, I want it in the form of an equation. Then it says, interpret the meaning of the slopes, B1 and B0 in this problem. All right, so there's my equation at the top. It says the slope, which is 0.00205, indicates that for a given GDP per capita, the predicted mean social usage percent is estimated to increase by 0.00205 for each 1% increase in GDP per capita. So for every 1% increase in GDP per capita, we expect the proportion of the population that's going to be using social media to go up by 0.00205. All right? So it seems like a pretty small number. You could make this 10%, and you could say for each 10% increase, it'd be 0.02, or it's going to have to be, it's a fairly small number there. So, but that tells me the relationship between X and Y. The y-intercept, 22.0689, indicates the predicted value for social media usage is going to be 22.0689 when GDP per capita would equal 0. Of course, you're not likely to have a population with a GDP per capita of 0, so it's just kind of where it would cross the x-axis if we continue to extend the line. And I'll need to make a change on that slide. Predict the average percent of social media usage if per capita GDP is 10,000. So what I do is I plug the 10,000 into my equation and solve for y hat, and that value is 42.5689. So that means I expect about 42.5% of the population to use social media if GDP per capita is equal to $10,000. Good. There we go. Is there anything useful in the equation? Examine the F value in answering this question. So I look at my ANOVA portion of the printout, and it says the value for F is equal to 39.368, etc. That's the value of F. The critical value of F is going to be found in my table. So how do I do it? I do it based on the degrees of freedom. 1 for the numerator, or the regression, 22 for the denominator. So 1 and 22 gives me the value 4.30, and that's my critical value of F. That means if my F value is greater than 4.30, I would reject the null. And this is what the null is saying, is that B1 is equal to 0 is the null, and B1 is not equal to 0 is the alternative. So I'm hoping that I can reject the null, which means there is a relationship between the X variable, which is GDP per capita, and social media usage, which is the Y variable that I'm trying to predict. And as long as this B1 value is not equal to 0, then that tells me, yes, there is a relationship. F is 39.37, and the critical value is 4.3, so it is much greater than the critical value. So therefore, I can reject the null. That means there is something useful in the equation. The X variable must be related to the Y variable. GDP per capita is related to the percentage of the population that uses social media. That's part D. Part E, provide the coefficient of determination using the adjusted value and interpret its meaning in the problem. Okay, so R squared is the sum of squares for the regression divided by the total sum of squares, and that R squared adjusted value is 0.6415. We go back over here and we can see it. 0.6415. The adjusted value is actually 0.6252 is the number. All right? So what does it mean? Well, what it means is the percent of the variation in social media usage that is explained by the variability in GDP per capita. So almost 2/3 of the variation in social media usage can be explained by changes in GDP per capita. Okay? Correlation coefficient. Okay, that's the same thing as multiple R. You'll notice it called over here. Multiple R is 0.8009. And so what I want to do is I want to compare that value with the quick rule. The quick rule says if the absolute value of R, or the correlation coefficient, is greater than or equal to 2 over the square root of 24, notice here it tells me how many observations I have, 24 countries, then I have 0.4083 is my critical value, and 0.8009 is my actual value for multiple R that is greater than the critical value, which is really what this is, and therefore I can reject, which says there is a significant relationship between GDP per capita and the percent of social media usage. And I'm pretty sure about that because this value pretty well corresponds to 95% confidence, and my number is almost twice as great as that number. So therefore, there does seem to be a strong relationship between those two variables. Part G, should the regression model be used to predict social media usage or not? How do you know? Well, what I want to do here is I want to compare the standard deviation of y with the standard deviation of y given x. Okay, so what I'm going to do is, the way I find this is actually through descriptive statistics. So I look up social media usage, which is my y variable, the dependent variable that I'm trying to predict, and the standard deviation is 15.83. I compare that with the standard error for the regression, and that value is found here under summary output, 9.69. So, because the standard deviation is greater than the standard error, that says I will have less error by using the regression model rather than not using the model. So basically what we're looking at here is, are the data points closer to the regression equation surrounding that line, or are they closer to the mean value of y, which is what my alternative would be? And the answer is we have less variation around the regression equation than we do the mean value of y, which is why I want to use the equation rather than the mean value of y as my prediction. Part H, examine the residuals to see whether they are normally distributed. The null hypothesis says the residuals are normally distributed. The alternative says the residuals are not normally distributed. So what I'm going to do is I'm going to compare the empirical rule, which tells me what percent of the values are going to be within 1, 2, and 3 standard deviations of the mean, and I'm going to compare it with the actual data that I have. 13 over 24, 23 of 24, 24 of 24. So these are then reported in percentages, and you can see the last two especially are very close to what I would expect. 13 out of 24 is not the correct number here, so we would need to look at that again. That's about 58%, which is a little less than 68 that we would expect, but it's not a lot less. The most important one here is going to be the 3 standard deviations, and it is approximately normally distributed. There are no outliers because all the values are within 3 standard deviations of the mean. So that tells me, yes, it does look like it's going to be normally distributed. Okay? At the 0.05 level of significance, determine whether the explanatory variable, GDP per capita, makes a significant contribution to the regression equation. So here, what I'm going to do is use the t statistic to answer the question. So the t value that corresponds to each of my predictors, here I only have one predictor, is, so let's go back to the printout so I can see where that came from. Maybe we don't have that. Let's see. Okay, we're going to have to see another portion of that printout in order to find where that number came from. So this is the value that we find on the printout. T-stat was 6.2744, and the critical value, the value I want to compare with, is 2.0 absolute value. Since this value, 6.27, is greater than 2.0, that tells me GDP per capita makes a significant contribution to the regression equation. Now it asks me, what is the 95% confidence interval estimate for the true population slope? And what is the meaning of this? Well, notice under lower and upper 95% confidence level for GDP, I've got 0.0014 and 0.0028. The key thing there, of course, is that both values are positive. Both numbers are positive, so that tells me if GDP per capita goes up, then I expect social media usage, that percentage, to increase as well. and I have 95% confidence that the amount of increase will be somewhere between these two numbers. The slope B1 does not equal 0, and it is somewhere within this range. Again, because it does not include 0, that's why I'm pretty confident that the slope is not 0. Okay? And finally, that's it for that. So one more slide here would be kind of, and I'll come back and add that later, but summarize what you've decided about the model. Okay? Do you think it's worth using? Do you think it's not worth using? So let me talk you through that, and then we'll make a slide to reflect that. Okay, we want to look at the F value first, which is in part D. So first thing we might mention is, in part D, the F value is 39.37, which is a lot greater than 4.3. So that's why I think that B1 is not equal to 0. Okay? Next thing I would comment on would be coefficient of determination, which is R squared. And the adjusted value for that is 0.6415, or close to that. And that means about 2/3 of the variation has been explained by the X variable, which is GDP per capita. Then, should the model be used to predict usage or not? The answer to that depends on the standard error of the estimate. And there it is, SY versus SYX. Since SYX was less than SY, that tells me use the equation. And I had no outliers. All the values were within 3 standard deviations. So that tells me the residuals are normally distributed. And my t-statistic tells me that there is a highly significant relationship between GDP per capita and the social media usage percentage. And so it's quite a bit different. That tells me I'm quite confident of the quality of this model. So therefore, I'd be willing to use it. Finally, the interval does not cross 0, so that tells me the slope is not equal to 0. So yes, I would use the equation. It is better than the mean value of y, and it does explain about 2/3 of the variation in social media usage.